No. Now the examples of the countable sets. Z. The set of all integers is countably infinite. What is the meaning of countably infinite? This is the countable set, which is finite also and infinite also. So it is Z is then countable infinite set. It is countable, but it is infinite also. Okay. Now let us define how to say that Z is a countable infinite set. We have always say that there exists a bijection map. Then we say that it is a countable set. So now define a map F is such that Z to n is a natural number, right? So f of n, which is equals to 2n, we define this function, right? 2n, if n is greater than 0, if n is less than equals to 0, then it is minus 2n plus 1. It is defined, well defined. Firstly, we check it is defined or not. It is well defined by for n is greater than 0, then it is 2n. N is less than equals to 0, minus 2n plus 1. F of 1 is equals to 2, f of 2 is equals to 4, f of minus of 1, then this number set. Okay. Now we say that how do you say that it is a bijection map? Firstly, well defined, it is well defined. Second is 1 1 and n 2. How to say that it is 1 1 map? F of n, when f of n equals to f of m gives you n equals to m, then it is this function is called 1 1 map. F of n is equals to 2n, for n is greater than 0, f of m is equals to 2m, 2 से 2 cancel out, so n equals to m. For n is less than equals to 0, minus 2n plus 1 is equals to minus 2m plus 1, 1 2n cancel out, minus 2 cancel, n equals to m. Now for onto map, how to prove that it is an onto map? F of n which is equals to m, so f of n is equals to 2n which is equals to m, so n equals to m by 2 which is in z. So for each n there exists m, so it is said to be a function is onto, right? For all the example it is trues. Now a countable set, a subset of a countable set is countable. What is the meaning of if z is number, integer number set, the subset is natural number set, then natural number set is the countable set. How do you say that a is contained in b, where is the b is countable? There is an injection map f into z plus. How? Restriction map of a function to a is an injection map of, always restriction map is a map which is always injective map, so it is countable. Okay. Now z cross z, z plus cross z